Hi. I know we all missed out on Pi Day activities this year. First, we had an Algebra 1 exam on Friday the 13th, and now we're out of school due to concerns about COVID 19. So here's my attempt at bringing some sort of pie into your life. No, not that kind of pie. This pie. So back in middle school, many students are asked to take a string and wrap it around the bottom of a can, like so. And then to take that length and measure it. This measurement is known as the perimeter, or circumference of a circle. And then you ask, can you measure the diameter of this can? After finding these two measurements, you're asked to find the ratio of the circle's circumference to its diameter. Do this a couple times for different sized cans, and you're going to end up finding that this ratio never changes. The only reason our numbers are slightly off is because our measurements are slightly off. What number do you think this really is? Here's my first can. I got some StarKist Chunk Light. We're going to wrap the string around and pinch where it's at. Now we're just going to measure this length of string. So that's at, wow, right on 11 inches. Okay. So our first circumference is going to be 11 inches. Okay. And then we're going to find our diameter of the same can. For that, we could just see 3 3/8 of an inch. 3 3/8 of an inch. So we're going to do the same thing. And that's right at 9 inches. And we're going to go through the center of the can here, and we are right at 2 7/8 of an inch. 2 7/8 of an inch. This is 9 7/8 of an inch. Right at the 3 mark. Right at 3 inches. Can you find the ratio of circumference to diameter for each one of these cans? Pause your video now. So with our first can, we have circumference to diameter, we have 3.26. 3.13 and 3.29. It's pi. So what is really fun about this ratio is it comes up in anything that involves a circle. If you can find a circle in something, then you can find pi. I have written a little JavaScript program at code.org because why not? I teach computer science too. So let's take a look. So as you can see, I've drawn a circle of radius 1. Now let's remember the area formula for a circle. It's A equals pi r squared. Now let's look at the square that the circle's inside of. What's its side length? Did you say 2r? That's because the radius is at the center of the circle, and that is half of the total width of the drawing. And the area of a square will then be 4r squared. Now, let's say that this circle inside of the square is a dartboard, and that we are very, very bad at playing darts. So bad that when we throw a dart, it is random. At the very least, it will land inside the square. So let's find the probability of hitting our target. We do this by finding out how much of the square the dartboard is taking up. The probability of hitting the dartboard would then be pi r squared over 4 pi r squared. The r squareds divide to equal 1, and we're left with pi over 4. The probability of hitting the dartboard is pi over 4. With a little bit of algebra, we rearrange this and we get that the probability times 4 equals pi. So let's do this experiment. We're going to simulate this with the app I wrote. So let me click Start. Much faster than I could play darts. We just threw 100 darts. Only 73 hit the circle. Let's use what we found before to calculate pi. The probability of hitting the circle was 73 over 100. That times 4 should equal pi. What does it equal? Doesn't quite equal pi, does it? Let's throw the darts 1,000 times. Let's take a look. We click Start. $791 hits. So, we come back to our equation. We had 791 hits out of 1,000 throws. That's our probability, 791 over 1,000. Multiply by 4, and that should give us pi. What does it give us? This time, our estimate for pi is 3.164. Getting closer to what we know. Let's try this one last time. Let's throw, I don't know, 250,000 darts. Let's watch. So how many darts actually hit? 196,364 hits. Now what is our estimate for pi? Now our estimate is 3.141824. This is getting fairly close to what we know as pi. So here's the lesson. Anything with a circle is going to end up getting you pi, no matter how you look at it. If we threw even more darts, we would get even more accuracy on our calculation for pi. I hope you're all doing well and staying healthy. I hope to be back in class and teach all of you very soon. Have a good day, and remember, pi is all around you.